Welcome, Calculus 2 students. We're going to learn some different techniques for integrating trig functions. There are many different ways to do each of these problems, and some of them get quite messy. First up, we're going to look at this cosine to the fifth power x. I don't have a way to do substitution here, but I'm going to rig it. I'm going to write this as cosine to the fourth power x times cosine x dx. This way I can rewrite cosine to the fourth in terms of a sine using that identity, the unit identity, cosine squared x plus sine squared x equals 1. And with this I can now write that we're going to use substitution. Now I'm going to let u equal just sine x, because if I do that, then du is cosine x dx. And now I'm going to go and do my substitution, and I'll get integral of 1 minus, this will be u squared, quantity squared, and then this cosine x dx is just du. Once I'm here, I'm just going to multiply this out using algebra and do this term by term. I'll do that. Alright, I have that multiplied out, so this is just going to be a u minus, and this is going to be u cubed. It'll be 2u cubed over 3 plus u to the fourth over, not u the fourth, u the fifth, over 5 plus my c, doing my back substitution, and I'll write that down. Alright, and here we have it with our back substitution. Next, when you have an even power sign, it's going to be a little dicier. This was nice because it was an odd, and I would do the same thing if it was sine to the fifth. I would have just replaced this with cosine. So I want you to think about anything with an odd power, and it's just a plain sine or cosine. I can use this same technique. When you have an even power, though, you're going to have to use your half angle formulas. So I will rewrite this thing then as integral of, and this will just be the 1 minus cosine 2x over 2 to the second power dx. Now I'm going to multiply this out and write that down for you. Alright, now this is all well and good except for that I have another cosine squared. So another even power of a trig function, I'm just going to use my half angle formula again. And with that I'll get 1 minus 2 cosine 2x plus, and this time my x is a 2x, so that'll be a 4x inside of there. So that'll be 1 plus cosine 4x over whole quantity over 2 dx. I'm going to simplify and collect a little bit here. At this point we can integrate using our regular techniques. I'm just going to write this as 1/4, and this will just be 3/2 x. On this one I will have to take note of this 2x inside of here, so when I go to integrate, you can, if you want, let u equal 2x, and note that you would have to have that 2 play a factor into, well, let's just go ahead and do that. So I just took that one out to the side just so that I can look at what it is, and then I'll just put it back in there. Note that this 2x, when I go to integrate, let's let u equal to 2x. That means du equals 2 dx, and I would have to do dx. Therefore, when I integrate, this 2 basically drops because I'm going to have negative 2, and then I will have cosine u times 1/2 du, whoops, integral of, and then those 2 cancel, leaving me with the negative sine u, and then plus c, of course, and then my u being 2x. So when I go to write in this right here where I'm going to write negative sine of 2x, this 2 was absorbed with this one here because of the 1/2, and that's going to happen similarly here. I'm going to get plus 1/8 sine of 4x, and then this is going to be then the plus c at the end, and then I'm going to distribute that 1/4 all the way through. And there's my final answer. And we're going to move on to a couple more and look at some more techniques. Here's a summary of some strategies to use, and they will save you a lot of time. You can go about this in your own way and it might work, but if you'll follow these strategies, you'll find it will be time saving for you. So I look at this and I say, okay, I have a sine to even power, cosine to an even power. This tells me that if both of them are even, use your half angle formulas. I'll get those on here. Alright, I got them on here. Now what I'm going to do is I'm going to do my substitution for my half angle formulas and see what I get. Not a pretty sight, but this is doable. What I'm going to do is, this will be a 4 down here and this will be a 2. I'm going to throw that out to the front, and then I'm just going to expand all of this. I'm going to multiply it out. Okay, I've done that. Still a little messy. I'm going to keep going. Here's cosine to an even power. I'm going to use my half angle formula. Here is one like our very first one. I'm going to change this using my identity function cosine squared sine squared. That way I can do a little substitution on this bad boy. Alright, so I'm going to go ahead and write these things down. Just breaking this into the pieces. I went ahead and did the first two because I could. I then did my half angle formula, and this one I broke apart using our first technique. Now what I'm going to do is bust this apart, and I can go ahead and integrate this one. I'm just left with this one, which is going to be a U substitution as I did at the very beginning. So I'll write all of that down for you. Alright, I have completed everything but the last one. Now on this last one I let U equal sine of 2x just like I did before, and then I did my du, and then I did my substitution. Now this is going to be, I can integrate this very easily and then do back substitution, and I'll write that down. And then of course I'll have to collect terms. Just did my back substitution, and interesting, these guys drop, and this just cleans up to what it is but without those two guys on it, and I'll just write that down. Done. Okay. What do we have next? Looks like we have an odd power for my sine. I have this cosine underneath. I'm tempted to kind of look at it as, you know, a sine over cosine tangent squared, but that would be times a sine. I don't think I can do anything with that, so I'm just going to go with the suggested method, which is looks like my sine has an odd power and the n is some real number. So I'm just going to split this off. I'm going to use the identity and see what I get from there. It might work, it might not. You're going to have to try things and then do some erasing on this. This is what I'm going to attempt, because if I do it this way, then I'm going to let U equal cosine x, and that means that du is going to equal negative sine x dx, and of course du equals sine x dx, and I'm going to do my substitution and I'll see what it looks like. And this will then equal secant x plus cosine x plus c. And that one's done. These reduction formulas are handy. I probably would use, I probably would just have used the identity for tangent squared and secant squared and reduce it that way, but let's see if we can do what they're asking us to do here where our n is 4. So I'm going to use reduction formula 3 where n is 4. And so this is going to equal tangent, so let me write down that n is 4 for this case. So it'd be tangent to the third x over 3 minus the integral of, this would be tangent to the second x dx. And then once I get to this point, I'll just use reduction formula 3 again, and I will get, in this one, n is 2. So let me write down what I had originally here. And then I'll say minus, and this will be tangent to the, and this tells me to do n minus 1, so it'll be the first, x over 2 minus 1, which is 1, minus, and then this would then be the integral of tangent then to the 0 x dx. This is just a 1, which then means that I get tangent cubed x over 3 minus tangent x, and then I would get, because I then had this, whoops, I would have to do this where I dropped my parentheses. I'm sorry about that. I was like, wait a second. So I dropped my parentheses. It's easy enough to do. You got to watch that business. Let's see. And then, of course, there are other ways to do this. But there we go with that one. Now, these sometimes get long and messy. So let's see what we got. We've got our theorem for the integral of tangent and cotangent, secant, and cosecant. And they've given us those. In the interest of time, I won't go through the proofs of those, but they are given in the text. Our strategy for solving these would be if I have an odd power on m is odd. Let's see, so I'm going to use this one right here, split off secant tangent, and write the remaining in those terms. So I'm going to do that right now. Alright, I've done this. Now my strategy here is to get everything in terms of secant so I can have a nice little du there. So here's my du that I'm setting myself up with right there. And I'm just going to write this as my secant squared x minus 1, just using my identity, and then secant cubed x dx. I will then distribute and then do my u substitution. So let me distribute. Alright, that's sitting pretty for me. Now I'm going to let u secant x. That means that du equals secant x tangent x. I'm going to do my substitution, and I will get, there's my du. This is going to end up with u to the 5th minus u cubed du. With that, I'll get u to the 6th, just do my straight up integration, minus u to the 4th over 4 plus c. Doing my back substitution, I then get secant to the 6x over 6 minus secant to the 4th x over 4 plus c. Alright. Now, were there other ways to do that? Could I have used the n equal even technique? Yes, I just chose to use m equal odd, but you'll still get the same answer whichever way you do it, of course. Okay, I have the last option here where m is even and n is odd, so I'm going to rewrite the even power of tangent in terms of secant using my identity and then see what I get. Alright, looks like I'll be able to use Theorem 7.1. I'm going to use that for this back end one, and I will be using my reduction formulas to work on this secant cubed x to see what I get from that, and I believe it's the formula 4, so I'm going to go get that one. Okay, I went and got my reduction formula 4, plugged that in. This is what I get. I see that these two little guys are going to combine so that I can then just use that theorem to get my answer. I'll plop that down for you too. Alright, there he is. So I'm just writing all of this stuff down. Oh. Alright, just copying that down from my theorem. I wrote it down and it was pretty straightforward after I started using those reduction formulas. And that's it for 7.3. Come see me at the Collaborate.